Hello friends, welcome back to Weld Tech QC, the YouTube channel of Lloyd's Institute of Technologies. I am Vincent. Today we are going to discuss about how to select the welding power sources. Today we are going to discuss about the second part of how to select the welding power source.
Okay, we'll discuss about this transformer. We'll look at the diagram. Input power goes to the primary windings and then to secondary windings. A transformer is a step down transformer. From the transformer, it goes to a reactor which stabilizes and adjusts the welding current. And the output is a weldable alternating current. Now we'll go for the rectifier, transformer rectifier. Okay, up to this area, it is almost same as transformer. From here, the changes starts. This is the bridge rectifier, or commonly called as a rectifier. So, as in the case of transformer, up to here it is AC, alternating current. Then it goes to the rectifier to convert the AC to the DC, which is a rippled current, rippled DC, which is not very smooth for welding. Now to change the AC to DC, a rectifier is added. Finally, an inductance coil. Okay, an inductance coil here, or you can call it a choke. Okay, this filters and smooths the rippled DC current to deliver to the welding arc. A very smooth welding DC current.
Now let us look at the inverter technology, inverter based welding machines. Inverter type welding machines are the state of the art welding power source, uses high technology and complex design.
Okay, here the diagram shows 6 main components of an inverter. That is rectifier, filter, IGBT, transformer, rectifier and choke. So here in the case of, unlike the cases of transformer or rectifier, in this case the AC input current directly enters into a rectifier. Okay, the input AC current immediately pass through a rectifier which change the AC to DC. This current at this stage is not smooth, but a rippled and still high volts and low amps, and not suitable for welding. This need to be filtered out here. This rippled DC is next passed through a filter to smooth the rippled DC, to smoothen the rippled DC. But the power is still high volts and low amps, which is again not suitable for the welding. The next component is the most important device, which is which makes an inverter from other varieties like transformer rectifiers, etc. And this device is called as IGBT. IGBT. IGBT means insulated gate bipolar transistors. It is actually a high-speed switching device which comes in various forms. The IGBT increases the frequency from a level of 50 or 60 Hz to a level of 20,000 Hz. IGBT receives only a DC signal. From here it comes to the IGBT, which is a DC. It never receives a AC signal. It will not be activated. And when it passes through IGBT and converts it to back to alternating current with an elevated frequency as high as 20,000 Hz, as we discussed just now. This is again passed through a transformer here, the transformer, to bring down the high voltage and low amps to low volts and high amps to suit for welding. This AC, the alternating current, is rectified to DC again through this rectifier. This rippled AC, the outcome of this rectifier will be a rippled direct current, rippled DC. This again goes through a choke to smoothens the current to suit a very good smooth welding. And the output current is a very smooth DC or AC-DC. Now, hope you got an idea about the internal components of three main configurations, that is transformer, rectifier and inverter. Now are you confident? Are you confident to make a decision which machine should I go for? I hope so. But more are required. Here are the answers for your questions. Constant current or should I go for a constant voltage? Let us see which welding process requires which type of current. Constant current power sources. These are especially used for SMAW, GTAW, that is TIG welding, and some applications in submerged arc welding, SAW. Okay, so if your job is involved with SMAW, that is stick welding, or TIG welding, GTAW, definitely you have to go for a constant current power source. Now we will see where the constant voltage power source will be used. Definitely for GMAW, that is the MIG welding or MAG welding as you call it, flux core arc welding or FCAW, and most of the submerged arc welding applications. Now again the question arises, what type of output current you require? The type of power source you have decided to go for either CC or CV. Now you see, you'll have to get what type of output current should I choose, AC or DC, or you require both AC and DC. AC is better to use on heavy plates in flat position, welding on heavy plates in flat position. It is very good deposition rate. And the DC only GMAW, that is MIG welding or MAG welding as you called, CO2 welding, etc. and flux core arc welding. Only DC will do. There is no other option. So your machine is supposed to be constant voltage, direct current power source for MIG welding and flux core arc welding. And in SMAW process, when you are using E6010 or E7015 electrodes, there is no option, you have to go for DC only. But for SMAW, your type of welding power source will be of constant current. Ideally, if you can prefer the DC for vertical and overhead position, the out of the position welding, that is vertical and overhead positions, the DC is always preferred. And of course, for stainless steel welding and non-ferrous welding, non-ferrous like aluminum kind of welding, always DC is preferred. Now, for some welding processes like JTAW and SAW, for some applications you have to use AC, or and some applications you have to go for DC. As far as GTAW is concerned, that is the TIG welding. GTAW means TIG welding is concerned. Your AC will work for the aluminum welding, and DC will work especially for the carbon steel, mild steel, stainless steel, etc. Will be working on DC. Similarly, for SAW welding, that is submerged arc welding, a DC power gives better control of bead shape, penetration, and welding speed. Arc starting is easier. DC EP polarity gives best bead with maximum penetration. However, high deposition rates and minimum penetration are obtained with DC EN, straight polarity. And for AC, the application is minimize arc blows. One of the problems while facing the welding is a arc blow. AC current minimizes the arc blow and gives medium penetration. So most of the use is of DC, and sometimes the AC is also used. Now let's sum up. What are the important points to be considered for selecting a welding machine? First of all, type of power supply. You have to select whether it is CC or CV. Now you got an idea. I have already explained it. Similarly, type of output current. Depending upon your application, you have to choose it. AC or DC, or you require AC and DC. Output capacity, that is the amperes. The type of job what you are going to weld, whether it is heavy, thick plates, thicker pipes, then you have to go for a higher capacity like 400 amps or more. But your work is comparatively in lighter sections or lighter plates, you can go up to even 250 amps. And more important, duty cycle of the machine also need to be considered. Very, very important. Don't forget it, please. Okay, now we have discussed about transformer, motor generator, rectifier, inverter, engine driven. After this, we have concentrated on three major configurations, that is transformer, rectifier and inverter. And finally, now you have to choose a machine, a power source, whether it is a transformer, a motor generator, a rectifier, inverter or engine driven. Transformer, after considering the power supply, output current, output capacity, duty cycle, then you have to choose the configuration, which one you have to go for. That is transformer, a rectifier or a motor generator, inverter or engine driven. Engine driven is normally used for site works where the power connectivity, line power is not available. So in such case, engine driven is always required. And otherwise, for normal usage, for your various applications, a transformer, motor generator, are also can be used, but better option according to my experience is always an inverter or a rectifier. Okay, an inverter which gives a fine quality welding, and it is compact in size, lighter in size, and it gives a very good DC or AC/DC current. And as far as rectifier is concerned, this is preferred when you have got continuous production welding. Such production welding, always rectifier is recommended. Inverter is also okay, but then you have to go for a heavy duty inverter based welding machine, which may cost high. So I hope now you got a fairly good idea for selection of your welding power source, and you are very confident to choose yourself the required welding power source. So all the very best to you and thank you.
So friends, that's all for now. We'll come back with the next video with a new topic very soon. Until then, goodbye.